So you know how some people who get COVID are predisposed to get high inflammation, the so-called cytokine storm. What differentiates different people from one another? One of the ways is potentially sugar, believe it or not. And we're going to be talking about in today's video how sugar is used by the virus to infect our cells, number one specifically, and we're going to correlate that as well with why people with diabetes might be more predisposed to more severe outcomes of COVID as well. My name is Dr. Mikola Rashik of Neurogenomics, and before we get going, I just want to remind you we have another COVID Q&A event coming up. Please stay till the end of the video to find out how you can get free tickets to that. So let's talk about the sugar. I brought up this concept already a long time ago, and typically when respiratory viruses, when they infect our respiratory tract, they land on what is called epithelial cells. Those are the type of cells that make up the respiratory tract, and those cells are coated with sugars, specific type of sugars, and especially these sugars, they are decorated with specific type of chemicals. They are referred to as 7-O or 9-O acetylcholine sialic acid. The name is not that important, it's just a chemical structure that can be linked on top of sugars. And by the way, sugars in scientific nomenclature can be referred to as well as glycans. And viruses, respiratory viruses, can latch onto those sugars, and that's how they can be infecting us. And electron microscopy has been used in the past, and I've introduced this technology in one of my videos in the past as well. It was used to determine how viruses do actually interact with sugar molecules, and it turned out that viral proteins, coronavirus, especially coronavirus proteins, they can have specific groove to actually recognize this type of chemical modification of sugar that I just told you about a moment ago. And it was of interest to obviously a variety of researchers to see and confirm whether SARS-CoV-2 could be doing exactly the same thing. And one group looked at use a similar type of approach to show that indeed SARS-CoV-2 does indeed bind to sugar molecules, glycans, that have this type of sialic acid modification that I just mentioned. And these are, as I mentioned, these are some of the most common modifications observed on top of different sugars that are decorating our epithelial cells inside our respiratory tracts. And these are also some of the most common modifications of all sugars of all of our cells. So this of course lands to that theory, another more evidence to the theory that has been proposed already a while back, that the very first interaction between the virus and the cells they're going to be infecting is via binding the sugars, and then they'll rest on top of the cells that they want to infect until the proteins necessary for the virus to infect the cell will come into contact with the virus. These proteins are tempress, which is involved in cleaving the spike protein of the virus, and then ACE2 receptor, which is of course the receptor that spike protein needs to interact with for the virus to gain entry inside the cell. There are of course other ways the virus can enter the cell, but these are the predominant pathway. So these authors were so interested about this that they even generated completely new compounds where they linked chemicals with different amounts of that sialic acid on top of it in specific geographical patterns, and they looked whether they could start working as potential antiviral drugs against SARS-CoV-2, and indeed they were able to show that these type of compounds that they generated were preventing cell infection by the virus. So this is a completely new potential method of how we could be treating COVID-19 in the future. Okay, so another study did something different. They were also curious how different sugars on top of our cells could be binding the SARS-CoV-2, and what they did is they inspected a number of naturally known sugars that are decorated in different manner, chemically decorated, which are the normal found sugars on our cells, and they tested them against binding to spike protein. All the variety of these sugars were tested against binding of spike protein. When you're testing a variety of chemical compounds, these compounds is referred to as a library. So technically they were testing a sugar library, if you will, for potential binding, and they were able to find that many different types of sugars indeed can interact with spike protein, both on the receptor binding domain of the spike protein. That's the same domain that is involved in interacting with the ACE2 receptor, and at least two types of different sugars potentially might be able to bind with the receptor binding domain alone, as well as what they also were able to show, that even other parts of the spike protein could be binding to sugars. So this again provided more evidence that sugars are involved in a normal path how viruses such as SARS-CoV-2 is actually infecting us. Okay. So too much brightness. So that's obviously one form of investigation, but now let's see how that can be linked to diabetes. And this is the interesting part, because it's been known that, number one, many of the diabetic patients who end up developing legitimate COVID-19, so like we're not talking about mild or asymptomatic condition, but one with symptoms, approximately half of them, according to some literature, end up experiencing damage to their heart cells. And the authors that investigated autopsy tissues from approximately 100 people, both people with diabetes who had diabetes prior to their death, or basically what would have been otherwise healthy individuals, and approximately 40% of them were indeed diabetic. And what they were able to show is that about 50% of all of the people in their autopsy revealed that their heart muscles were infected with SARS-CoV-2. Okay, but out of that, 80% of them or so were the diabetic patients, and just maybe around 40 or 30%, maybe around 30%, I believe it was, were those who were non-diabetic. So clearly, the diabetic patients had much greater predisposition of having their heart cells, cardiomyocytes, infected by SARS-CoV-2. But what's more important also in what the authors looked in that particular research is that the heart cells of diabetics were more likely to express ACE2 receptor, were also more likely to express that TMPRSS protein that cleaves the spike protein to help the virus be more infectious. And also, they were more likely to have both the ACE2 as well as TMPRSS be more covered with sugars. So these now we're talking about the receptors, and even TMPRSS proteins were more decorated with sugars. Now, what were the molecular impacts of that? When it came to ACE2 receptor, its decoration with sugar did not enhance binding to this spike protein, but it helped basically what is referred to as oligomerization of ACE2 receptor, or literally, in other words, the ability of that receptor to clump together. And of course, if you bring more of ACE2 receptors together, then they're more likely to catch the virus. So that's one of the ways why diabetic people are more predisposed to experience heart damage post-infection. And what's more, these authors also took ACE2 receptor, and they incubated it with sugar of basically solution. So they simply let that receptor sit for a number of days in sugar solution, and they were able to show that ACE2 receptor naturally started to be coated by sugar. So this is non-enzymatic. There were no specific proteins that actually attach the sugar to the receptor. The sugar can be like a Velcro. It can naturally start attaching to proteins. And that's exactly what they were seeing with ACE2 receptors as well. Now that's problematic, and the reason why is because when proteins are decorated with sugar like that simply sugar that's available floating in the blood, which is what happens with diabetics. They have higher amounts of sugar, or they have the risk of having higher amount of sugar floating in their blood than non-diabetic individuals. And when you have proteins being decorated by sugar like that, it can disrupt their proper functioning. So and it can literally prevent them from forming proper three-dimensional shapes. It can prevent them from being able to interact with their appropriate receptors. And that's one of the reasons why diabetic people are at higher risk of experiencing disease conditions than otherwise healthy individuals. This is one of the reasons why sugar levels contribute to the eventual destruction of many different cell types, such as neuronal cell types, their heart, kidneys, their eyes. That's because of the unfortunate increase of sugar floating in the blood. So this is how you can correlate sugar levels directly to pathogenesis as well. Okay. And the last thing, I can mention that I read another paper that also discussed the concept that what's been observed is that, since we're on topic on diabetes, is that post-SARS-CoV-2 infection, there has been an increasing amount of those patients who've been infected, increasing amount of developing type 1 diabetes. So somewhat unusual. And it's been noted that post-SARS-CoV-2 infection, people might basically require higher levels of functioning insulin, and they basically have a molecular footprint of what you would expect from diabetic person. And this particular paper analyzed whether spike protein can bind directly to the islet cells of pancreatic islet cells. So the cells that are involved in the production of insulin, and they were able to show that explanted cells, human cells like that, so not in human, they were able to show this in the lab, were able to indeed bind spike protein as well. And this is partially one of the reasons that might explain why some individuals, likely because of their predisposing sugar patterns, might be at greater likelihood to potentially develop type 1 diabetes post-SARS-CoV-2 infection. It's all related to sugar, so I'm continuing with sugar. And I'm going to bring up one last wild concept, still attached to the sugars, and that's the antibodies. So of course, when we get vaccinated or we get naturally infected, we produce a variety of different antibodies. Post-vaccination, the primary antibodies you produce are referred to IgGs. Now, IgGs are very important antibodies in our body that help fight infections. They predominantly are reserved to be present in the blood. And those antibodies, IgG antibodies, they also can be decorated with sugar. In fact, they all are. They have a specific pattern of sugars, and that pattern of sugars is also different in disease versus health. So in one of the videos, I mentioned how antibodies are used by our immune cells in order to actually fight infections. So what happens is when you have an antibody coating a virus such as SARS-CoV-2, those antibodies, they still have a stalk sticking out, and that stalk is called FC. By the way, that stands for crystallizable portion. So hence that the C stands for crystallizable fragment. That's what FC stands for. That has to do with chemistry and ability obviously ability to crystallize that element of the antibody, which basically means it allowed in the past to get a very nice complex three-dimensional understanding of the antibody. And basically this FC portion is recognized by receptors on our different immune cells, such as macrophages as well as natural killer cells. and then they start destroying both the virus and the antibody, and this is referred to as antibody dependent cytotoxicity. So basically macrophages could destroy it, or natural killer cells can also be used to destroy such complexes, and that's how you clean up. So I introduced that concept in one of my past videos as well. Now, however, how that stock, the FC stock of antibodies such as IgG, how they are differently decorated by sugars will determine to what degree the different immune cells will respond. So, and here's what's also very interesting, is that it was discovered that in COVID-19, there are different sugar patterns that predisposed you to more severe COVID if you had specific type of sugar patterns on your antibodies than if you did not. So one example was actually, in fact, presence of that sialic acid we already talked about on the sugar molecules of the antibodies. Another one is whether the antibodies had specific type of sugar or not, which is called fucose. So those who had less fucose were more likely to bind to the type of receptors on immune cells that would result in inflammatory response of these cells, okay? And if you had a different type of sugar, then you could interact, or if you had that sialic acid, you could bind different types of receptors which would not be pro-inflammatory, but quite the opposite. It can be anti-inflammatory. So even if you have antibodies, depending on what sugars you have, it can totally change how your immune system will be responding. And this is so specific that some authors even propose that we actually should be using this as a viable biomarker, meaning we can investigate this information on antibodies immediately post-infection by the virus, and depending on what sugar molecules are present on the antibodies you have in response to the virus, it can determine whether that person will experience severe COVID or not. So very, very interesting. And there's a number of different studies been published that looked at this. Another one predisposing factor towards severe COVID, besides this I'm trying to remember how to say it. Fucosylation. It's a hard word to say, meaning you don't have the fucose sugar, will predispose you to inflammation. Another one is it depends on how the sugars are branched off. So when sugars are attached together, you can create branches, like tree branches almost. And the sugars on antibodies, they have two branches, or you can also call it two antennae. And whether you have fewer of those antennae or not present on those antibodies reduces your likelihood of the immune cells from being able to grab those antibodies and kill the antibodies and the virus in that cytotoxic manner. So that's another aspect of how sugar composition of the antibodies can actually influence potentially COVID outcomes. So sugar plays a role in multiple different ways. It plays a role in how the virus can latch onto our cells. It plays the roles in how the virus can interact with the receptor, and it can increase the dynamic of that interaction. It can also interact the antibody response post-infection as well. And while this might be surprising, obviously sugar is coding everything in molecular biology, all organic matter pretty much almost. So like all of our cells, I mean, have some sugar on them, and sugar levels that we provide available to our body also can have influence on how all of these molecular compounds will be decorated by sugar as well. And clearly with the examples I just mentioned with diabetes could potentially be influencing outcomes. So that's really what I wanted to bring up for you in this video, in a deeper dive about sugar. All right, so if you stayed with me till this moment, I just want to let you know very quickly, I have another COVID Q&A event coming up. Basically, it's an open mic session about COVID related questions, all levels are welcome. If you want a free ticket, then the first 10 people who subscribe to our newsletter will give you a free ticket. If you are already a subscriber and you never manage and you try to get a ticket, then email us and we will try to send you a free ticket as well. And we'll try to send you two, just so you can come with a friend ideally. We also have another program coming up, which is a program that I composed with two other experts, financial expert as well as mental health expert, and pretty much we build a program that we offer for business owners to offer to the employees, where we discuss about well-being from multiple different arenas of life, hence the three of us coming together. So we want to basically bring a concept of very holistic personal well-being, and we would just simply want to make sure that people know this information to be able to take advantage of this type of different knowledge. And finally, I want to also remind everyone we have a ongoing survey about your potential interest at looking what is referred to as biological aging. And the reason why is because this is an epigenetic test that looks basically epigenetic information, and that can determine biological aging of a person, which is different from chronological aging, and you can use that information to actually determine how likely you are predisposed to negative health outcomes. And to give you an example of that, even the papers discussing the type of sugar molecules attached to the antibody receptors, those authors have also proposed that potentially the pattern of those sugar molecules on the antibodies can be used as a biomarker of biological aging in a similar fashion to epigenetic aging. How epigenetic testing can be used for monitoring your biological aging is because there's more and more mounting evidence indicating that it's your biological aging that can inform quite accurately your own predisposition to the effects of viral infections such as SARS-CoV-2 and COVID-19 development. So please check out the survey as well as the subscription to the newsletter are provided in the link below. So if you like this video, please give us a like, subscribe to the channel, and leave a comment, share the video. Those are all important. Once again, thank you to everyone for the super thanks, and we look forward to seeing you next time. Bye everyone.